Hi guys, and welcome to another NBT exam preparation video. Today we are going to go over our NBT Maths preparation. If you are looking for NBT AQL, that's the quantitative literacy section, you are in the right place, but just not on the right video. So what I will do is I will post a link in the description to the quantitative literacy question so that you can do those. Now let's get to the maths. Oops, let's do that. Okay, so question 15 asks the value of AB if 2A equals 3 and 9 to the B equals 16. All right, so we are going to use logs because whenever we see exponents, we're usually going to do logs because logs is a way of getting the exponent out because our unknown A is an exponent. For those of you who are doing maths literacy and when you hear the word log, you have no clue what I'm doing, do not worry. I'm going to show you another way of doing this. And that goes for the pure maths guys as well. If you're not too familiar with logs, there is another way. It's a little bit of a trick, but I will show you the other way next. But if I see this question and I'm not too sure what to do other than do logs, I would start with logs because this is probably what they're wanting. So I'm going to just show you guys something before we actually do this question. And that is just something that you need to remember, which is log base number equals exponent. Now, this is a little trick for logs that is going to help you out a lot if you find yourself not being able to answer log questions. Log base number equals exponent. Okay. What that means is, well, the exponent, right, is the thing at the top. And if you think of a base, right, the base of a tree, the bottom of a tree. So an exponent's at the top. So I'm going to circle that in yellow. And notice how that is our way of getting the exponent out. And if you just remember, so just repeat several times, log base number equals exponent. Log base number equals exponent. So when I have students, I just say, guys, remember, log base number equals exponent. I keep saying it over and over just to get it in your head. Because when you remember the rhyme, then the part where you have to get this into logs is easier to remember. Now, your number, think of as the number. The number is the thing by itself. That's a number. Okay, so log base number equals exponent. So let's do that and see how we go. So log for the first one, right? So log, and the base is 2, right? Because that's the thing that has the exponent at the top of it, like the base of a tree. Base number is the number by itself, and A is the exponent. And notice now we have isolated A, right? We've isolated A. So when I said that your logs is a way of isolating your exponent, now you see why. Okay, and the next one, log. And then again, what's the base? Say it with me. If you're at home. 9, right? The number by itself for the next part is 16. And that is equal to the exponent, which is B. Okay. And what they are asking for is, what is AB? So we have A and we have B. So A times B is equal to this thing here. Okay, and now we've got it into logs. Now, obviously, you don't have a calculator. So now that I've got this, I'm going to stop with the colors. Multiplied by log 960. Okay, now the next thing you have to know is if you have log and you have an A here, well, let me not call it A because that may confuse the matters a little bit. Let me just call this x, and I'll call the other thing y. Log x, y equals. Now, what you can do when you see this is you can move one thing to the top, which is, notice the x is a little bit at the bottom anyway. So that goes to the bottom. So this is just a way you can write it. You can write it as log x at the bottom and log y at the top. Okay. Okay, so what I'm going to do is I'm going to write these now as, so it'll be like I have done here, like what I've done with the log xy and the log xy. So I'm going to write it as log 3 over log 2. Okay, so that's the next step. These here are log rules. Okay, they're things that you kind of have to know. So for those of you who are doing pure maths and matric, this is going to help you with your studying for your final exams as well. So the things that I'm putting rectangles around are just log laws that you need to know. Okay, if you're doing maths lit and you're completely lost, do not worry. Try and follow along. It's good to be able to do logs just in case they do come up. But there is another way which hopefully you find a little bit more, a little bit easier, let's put it that way. Okay, so this log 2, 3, I'm going to write as log 3 over log 2 times by, and then the 16 and the 9 I'm going to write as log 16 over log 9. Another log rule coming up. So this question, it's a fantastic question in that for those of you who want to learn your log laws before matric, and you don't remember them, the other thing to know is that if you have log, I'm just going to call this x and y. The x and y part's not important. X and y. But the y is to the power of a number. Let's make it to the power of like c. It can be written as c. So the c, the exponent, can go to the front. Okay. And so log x, y. Okay, so I'm going to put that in a rectangle as well, because that's a law. It's full of laws, this question. So these you can't do anything with. The first part, log 3 over log 2. But the next part, 16 is equal to 2 to the 4. Okay, 2 times 2 times 2 times 2 is 16. So that is then log 2 to the 4. Okay, how do we spot this? Well, if you see log 2 and 16, you know that 16 is 2 to the power of something. And the 9, we know, is 3 to the power of 2. So there's a connection here between these numbers. There's not a coincidence. Okay, and so we end up getting log 3 over log 2. And this rule where you can bring the exponent to the front then becomes then, oops, that's supposed to be log 2 there. Oops, 2, oopsie. Oops, my computer's struggling. There it is. About 7 seconds too late there. And then the 2 can go to the front, leaving just log 3, right? Log 3, and that is log 2. Oh my goodness. Come on. Maybe I need to close a few programs here. Okay, now we notice we can cancel the log 3 and log 3 and the log 2 and log 2, and we're left with 4 over 2 which is 2. Okay, for those of you who spent the entire question going, I'm so lost, let me just see the other way to do it. The other way to do it, I was just trying to figure out another way of doing it before I did this video. And so it kind of reminds me of when I was doing the Maths Olympiad. You'd kind of try and figure out different ways of doing it. And it's not always so obvious, but let's give it a go. Okay, so I'm going to write this again. You have 2a to the 3, and you have 9b equals 16. Now, what happens if I was to say, well, 2a times 9b, right? 2a times 9b, 9 to the b, is equal to then 3 times 16, right? Because if that's equal to that, and that's, I'll just do it in blue. So if green is equal to green, and blue is equal to blue, then I can say that green times blue is equal to green times blue, right? So don't know if the colors made it sound more confusing. 3 times 16. Okay, well, let me just explain that again. Let's say that a is equal to 2 and b is equal to 3, right? Then a times b is equal to 2 times 3, which is equal to 6, right? And we know that 2 times 3 does indeed equal 6. So a times b must equal 6. Okay, so what you're going to say is then 2a times 9b is equal to 3 times 16. Okay. Now what? Well, we can write this 2 to the a, or we can write the 9 to the b. We can write this, we can keep this as 2 to the a, but we can write the 9 to the b as 3 to the 2b, right? Because that's 9 is 3 squared, right? So from our exponential laws, we can then multiply the exponents out. Okay, and then we keep that as 3. We keep this as 3. But then we write the 16 as 2 to the 4. So what I've done here is I've made everything what we call prime factors. Okay, so get the prime factor. So what's the smallest factor that you can make? So 16, the smallest would be 2 times 2 times 2. That would be the prime factors. You have done prime factors in sort of grade 7, so maybe hopefully that helps. Remember, you did the lather method. 16 divided by 2 gives you 8, divided by 2 gives you 4, divided by 2 gives you 2. And then you can see, 2 times 2 times 2 is 2 to the 4. Okay, I think of maybe sort of overdoing the explanations on this. For those of you who do want quick answers to this question, let me just mention that I do these exact same questions on our main channel, Smart Prep, where I don't go into as much detail because I'm assuming that you are sort of pretty au fait with core maths. Okay, so on this channel, I like to take a little bit more time to explain to you what's going on so that you understand the underlying concept so that you are able to answer similar questions. Okay, so what do we notice? Well, the 3 has an exponent of 1, right? Because the default, there's a ghost 1, right? 3 to the 1. So if I look at it, I can then isolate. So do you see the 2 there and 2 there? They have the same base. And 3 and 3 have the same base. So I could say that then A is equal to 4. Right? That's equal to 4. And I could say that 2b is equal to 1. Okay. And so then b is equal to, divide both sides by 2 is a half. And so b is equal to 4 times a half. And 4 times a half is 2. Okay, post in the comments which method you found easier. Or did you find both just too difficult and you're just going to skip this question? Let me know. Those are the two methods. I'm going to leave the log method here in the memo because this is the correct way to do it. The other way is sort of a more maths Olympiad way where you try, let's say that you didn't know what logs are, but you just like to problem solve. Then that way with the exponents. But it doesn't, of course, work every time, whereas logs, those are always going to work because you are isolating the exponents. All right, so you're not relying on things working out quite so nicely in terms of the mathematics. Okay, now question 16. What we notice here is the difference of squares, don't we? Difference of squares. Perfect square minus perfect square. Perfect square minus perfect square. And they want us to evaluate the sum all the way down to 2 squared minus 1. So let's say I did the first part of 52. So difference of squares, right? 52 minus 51. Sorry, let's do, 52 minus 51 and 52 plus 51. Okay, plus the next one is going to be the yellow one. Guys, if you are studying for your NBTs and they're coming up this Saturday very, very soon, try and do this with me. Try and figure it out. Now that I've kind of showed you what's actually happening, try and see if you can't do it yourself. Okay, and it goes all the way to the 2. So there's a dot here, right? And then it's 2 minus 1, 2 plus 1. Okay, well, what we know quite handy is that we end up getting 52 minus 1 is 1. And then times 93. And then we get 50 minus 49, which is 1, times 50 plus 49 is 89. And then all the way to the end, which is our 2 minus 1, which is 2, and then it's 3. So it'll be 1 times 3. Okay, if I was to carry this on, it would be, it goes 50, 52, so the next one would be 48, right? And then 48 plus 47 would be 90. 48 plus would be 85. So we notice there would be a pattern here. Okay, so I'm going to do away with now the colors, especially because this one this one was supposed to be in yellow anyway. I'm going to be doing away with the colors because now the idea is that you should spot a pattern. Okay. I'm going to do I'm going to sort of do the other one that we must start just so that you can see that extra pattern. So I'm going to say it would be 1 times. So if you were to carry on this pattern, right, it would be 50, 40, 48 plus 47, right? And be 1 times that. And that's, as I said, would be 85. Not 85, 95. What's going on with me? This is 103. Wow. Who's shouting at their screens? What? It's 95. 48 plus 47 is 95. Okay, and it ends at 3. In green. Okay, so what we end up getting is, as I said, I'm going to get rid of the colors now. 103, 99, 95, 91, all the way down to 93. So what we have here is an arithmetic sequence where the difference is 99 minus 103 is -4. 95 minus 9, -4. -4. Okay, so A is our first term, which is 103. D is our difference, which is -4. And the number of terms is equal to, notice it goes 52, 50, 48. It's going down by 2. So how many pairs? Well, 52 divided by 2 is 26, right? So there's going to be 26 numbers, right? Because if this was, 50, it goes, as you can see, it gets all the way down to 2, right? So 52 all the way down to, so we know that there are 26 terms all the way down to 2. So 52, 50. So this is the amount of numbers that we're going to get, okay? Another way of, so there's 2 ways of doing this actually. The first one is to, now we know that it's an arithmetic sequence, which is n over 2 multiplied by 2a plus n minus 1 times d. Okay, for the pure maths guys, you know this arithmetic sequence sum, or you should. And so it would be 26 over 2 times by 2 times the first term, which is 103, plus n minus 1. Now, n minus 1 is 26 minus 1, which will be 25, times the difference, which is -4. Okay, and we end up getting 2 times 103 is 206. 25 times -4 is -100. And so you get 13 multiplied by 106. 13 times 106. Well, if I halve 106, I get 53. And double 13, I get 26. Right, so I can write 13 times 106 as, well, as 26 times 53. So the answer is B. Okay, let me just explain that last bit quickly before I show you a different method. 13 times 106 is 2 times 53, right? 106 is 53 times 2. And so 13 times 2 is 26 times 53. So it can be done the other way. Okay, another way to do it is you can multiply the number of terms, which is 13. So there's another formula, which is you do the number of terms multiplied by the first term and the second plus the last term. So the number of terms, which is n over 2, multiplied by the first term plus the last term. And let's just explore that. So what you have is this term is 103, and then the last term is 3, right? the term before the 3, remember it goes down by 3 each time, will be 7, right? So 103 plus 3 gives you 106. 99 plus 7 will give you 106. So what this is telling you is that each of these couples, the first term and the last term, the second term and the second to last term, the third term and the third to last term, those will all sum to 106. And then you go, well, how many of these pairs are there? Right? Well, there was 52 down to 50. We already said that it was 26 terms, so there would be 13 pairs, right? So it would be n over 2, which is 26 over 2, which is 13. That's where the number of pairs are. And then times the first term plus the last term. Okay. Which would give you 13 times 106. First term plus the last term is 106. Okay, and then in the same way that we did what before, we now can make it 26 times 53. Okay, we've started off with 2 pretty tricky questions. Let's see if the next one is also hard. Okay, so what this means is the inverse. So when you see f to the minus 1, a term like inverse might be confusing to people who are doing maths lit. So let me just say, when you see f to the minus 1, just swap x and y. Swap x and y. Okay, so f of x, we actually can just call y. Okay, so whenever you see f to the x, that's the same as saying y. So you get basically saying y equals 2x over 1 minus 3x. And what we have to do is we have to swap x and y. So the y we call now x, right? And the x we now call y, right? So this x we now call y. And that y becomes an x, right? So we swapped x and y. Okay, now we have to make y the subject of the formula. Okay, so we have to get y by itself. So what we have to do is we have to cross multiply. So we take this 1 minus 3y to the top of the other side. So we say x, I'm going to keep the colors just so that you know what's going on. So x to and then the 1 minus 3y, when you cross multiply, goes to the top of the other side. When you go across the equal sign and it's 2 fractions, the bottom can go to the top of the other side. It's taking a bit of time, but hopefully you're getting this down. I would advise not to just lie in your bed or whatever and do this. I would advise trying to actually do it yourself, because passive watching is not as good as actually doing, right? So I should just mention the x is like x over 1, right? 10 over 1 is just 10. So that x can be written as x over 1. So the 2y is basically being multiplied by 1, right? And it's staying 2y. Okay, now I can stop with the colors, I reckon. So x times 1 is x. X times negative 3y is negative 3xy. Let's get rid of some of this stuff. Equals 2y. Okay, now my ultimate goal is to isolate my y, because my y will basically be the f minus 1 over x, because it's the inverse. So that will be the new y after everything's swapped. Okay, so we have to take the negative 3xy to the other side. Okay, so it becomes 2y plus 3xy, because when you take something to the other side, it changes sign. Now you take out y as a common factor. So you get 2 plus 3x on the one side. Okay, and now you simply divide both sides by 2 plus 3x, because that is how you isolate y. Okay, so y is equal to, I divide the 2 plus 3x, so the y, if I divide by 2 plus 3x, you see they would just cancel. And then you get on the other side x over 2 plus 3x. Okay, and that should be the ball game. Hopefully we've got that as an answer. X over 3x plus 2. Okay, so it's A. Okay, because 2 plus 3x is the same as 3x plus 2. Okay. The line y equals 7x plus p is a tangent to the graph of f of x equals 3 of k x cubed plus x, where x is equal to negative 1. This is calculus. Okay. Whenever you asked about tangents and you give an f of x, what you have to do is you have to find the derivative of x. So in my other videos, I did kind of explain. If you already know how to get the derivative, great. If you don't, I'm just going to explain it briefly with a few examples. X to the q, x3, the derivative is 3 times the front. So the exponent times the front, which is 3. X, and then you take 1 off the 3 to get x squared. Okay, I'll do another one. 2x to the 4. Okay, the pattern is the exponent times the front. So 4 times 2 is 8. Take 1 off the 4, becomes 3. Okay, if you're at home, you haven't seen this, you're doing Maths Lit, you've never seen this calculus before, it's okay. We'll do 3 more. First thing, 2 times 3 is 6. Then you take 1 off the 2. So 2 minus 1 is 1. So then it's x to the 1, which is just x. Okay, hopefully if you've never seen these before, you're going to do the next one by yourself. I'm going to put a 5 here and a 2 here. Tell me what it is. 5 times 2 is 10. Take 1 off the 5 gives you 4. Okay, so those are the derivatives. Okay, so the derivative of 3 of k, I'm going to write that here. Kx cubed, right? 3 times k is 3k. Take 1 off the 3, you get 2. So that is the derivative of the first bit. The second part is just x. Okay, now I'm just going to, the quick way is anything with no exponent is just whatever is in front of that x. So if x does not have an exponent, the derivative is just the number in front, which is just 1. So let's say it was a third x, right? The derivative would be 1 over 3. If it was kx, the derivative would be k. Okay, why? Because think about it. You're saying x to the 1, right? Well, 1 times k would be k. But then x, 1 minus 1, would be x to the 0, right? 1 minus 1 is 0. Anything to the power of 0 is 1, right? So that's how you get k times 1, which is k. Okay. Is equal to k. Okay, so a little bit of a long video because I am taking the time. As I said, check out the main channel where I do all these questions much faster, but I don't go into the explanations like I do here. And the reason I'm doing that is because that was asked for. We had a lot of comments on the main channel from guys doing Maths Lit saying, I am so lost, I do not know what's going on. So I decided to do on this channel something more tailored towards people who have no clue what's going on. Now, it's still tricky. I do understand that, but you still have to write these NBTs. So you've got hopefully some time. Rewind the video, watch again if you're not sure. The other thing, there is a little thing to mention. Okay, so remember, I'm just going to put this derivative while I'm talking. So it was 3kx squared. If you do not know what's going on, do not worry too much about having to now learn an entire branch of maths that you've never seen before. Know that these questions come up. They are questions. There is a library of these NBT questions that they have. And what they do is they just take from the library and they put that test. It's all computerized, all marked by computers, so it's super fast for them. So that's why it's multiple choice. And so they have these bank of questions, and then you get assigned random questions. So what I'm saying is, if you do all of these questions, so if you go to the link in the description, which has all of the past papers, and then you find questions that you have no idea what's going on, simply just learn the answer. And as you see on our main channel, people have come back in the comments and said, guys, thank you so much. The test was exactly as the questions came up here. Okay, so do not worry too much. Do not stress. Just keep practicing, keep doing all these questions. Try and understand as much as you can. But I do understand that you are not going to be able to get everything into your heads if you are not strong at maths. I do get that. Okay, so ultimately we want an excellent NBT score with the tools that we have. Okay, we're not expecting 100%, but if we can get 70s, 80s, that'll be fantastic. And I do believe, and I've done this, I've had private lessons with people who've done their NBTs and they've done Maths Lit and they've come back and they've gotten over 80. So it's just about putting in the work. Okay, so when you see tangent, find the derivative. Okay, just blindly put in the derivative. Then what they say is at the point x equals -1, find the value of p. Okay, so now what they're telling you is this is the slope and it's a tangent. So basically what they're saying is 7p is a tangent to this graph at the point where x is equal to -1. So what they're telling you is the slope where x is -1 is equal to 7. Okay. So we can now figure out what k is. And how do we do that? Because we know that the slope where x is -1 is equal to 7. And this comes from the fact that you know that y is equal, I'm using the wrong thing, sorry. Y equals mx plus c. Y equals mx plus c. Okay, that's a straight line, plus c. Okay, so m is our slope. Okay, so what they're telling us is that the slope is 7 because they're saying that's a tangent to the graph. So let me just draw that actually. So in red here, if that is a straight line and this is the graph, it's a tangent to the graph. So they're saying that the slope of this line, this red line, is 7 at the point where x is equal to -1. And so what we can do is we know then the slope, but then the slope, which is what we just figured out, 3kx squared plus 7 plus 1 is equal to 7, where x is equal to minus 1. So let me just write that down. So f to the minus 1 of x, sorry, not f to the, f dash of x is equal to 7. Okay. So actually, let me say this, because we know it's at minus 1. So let me go even further than that. So the slope is equal to 7. We got that from here, from the 7 here, the red 7. Okay, but now we've figured out what f of x is, f dash of x is, so we can replace the x with a minus 1 and make this whole thing here equal to 7. So negative 1 squared. So I'm making that part there. I'm writing this part first. 3k plus 1 is equal to 7. And now we can figure out what k is. Okay, negative 1 squared is just 1. So it's 3k plus 1 equals 7. 3k equals 7 minus 1, which is 6. So 3k is equal to 6. Divide both sides by 3, and we get k is equal to 2. Okay, but that's not what they want. They want the value of p. Okay. Now what we can do is we can figure out another point. Okay, so we know that now f of x is equal to 2, because k is 2, x cubed plus x, right? And now we at least know that we can get the point, right? Because we know that now this is a change in this graph, this y equals 7x plus p, that is equal to the graph at x equals minus 1. So now what we can do is we can say f of minus 1 equals 2 negative 1 cubed plus negative 1. And we get negative 2 minus 1, which is negative 3. So now we know that y is negative 3, where x is equal to negative 1. And so now we can solve for p, because we have a value for y and a value for x. This is a crazy long multiple choice question. Is the juice worth the squeeze? You tell me. I am thinking that there's probably going to be juicier marks available, but nonetheless, this could be a matric question. This could very well be an 8-mark matric exam question. Okay, so we say negative 3 equals 7. Okay, so we're replacing the y with a negative 3. And we're replacing the x, let's put that in yellow, with a negative 1. And that is going to help us figure out what p is. Okay, and p plus p, right? Take the minus 7 to the other side, becomes plus 7. So 7 minus 3 gives you 4. So the answer for that one is 4. Now, the next one I guarantee you is not going to be as long as this. It can't be. They can't all be like this, surely, right? And it's not. There will be some easier questions. Okay, so P is 4. So the answer is B. Let's move on to the next one. And this is better. Okay, now I'm glad that we did go through so much work, especially for those of you who didn't, who knew nothing about calculus before. Okay, so I'm just going to recap what we did. So remember f dash of, well, they've called this k, right? And this is, so remember f dash of x is the slope, okay? The slope. So another thing I'm going to say is when f dash of x is equal to 0, that means the slope is 0. Now, when the slope is 0, that is a turning point, right? Because if I draw a tangent along the turning point, we see that there's no slope. It's like a flat road. There's no. So that's an important thing. So what are we saying? When you see something like this, it's saying how many values of k will f? So k is some number. What this is basically saying is how many turning points? 1, 2, 3. Isn't that much better, right? And we should go down and we should find the answer of 3. There it is. Okay, so if we compare how much work we just did for that first question, if you see something like this, I would probably skip it and try and find the easier marks. As I said, I'm glad we went through it because I have to. You have to get given the answers. And hopefully this question comes up and you just remember that the answer is B4. Okay. If it doesn't, then, well, I suppose then you probably hopefully get some easier ones. But the point is, I'm going to leave it there. Okay, guys, so as you can see, we had a range of difficult to easy questions, or easier questions, but all pretty tricky questions. Did a bit of work there, so please like, subscribe, all that good stuff. As an incentive for you subscribing, liking, I noticed that on the first video that I did, we got about 300 views now and maybe 4 likes. So, but a lot of people were watching the video till the very end. So people were watching and then I think just going on to the next one without helping me out and subscribing and liking and all that stuff. And yeah, I mean, it is now 10 o'clock at night. I'll be recording some more videos, but what I'm going to do is I'm going to hold those back and I'm going to share them so when this video gets to 20 likes, I will then post a new video. So I really appreciate you helping me. There is an incentive, even if you're writing tomorrow and it's not going to arrive at you in time, at least then you'll be helping someone else out. And if you're doing your matric exams, as soon as I'm done with these NBT videos, I'm going to be doing some maths and Maths Lit past papers and all that stuff. So yeah, I really want to keep doing this, but yeah, I also hope that I've earned enough in this video to get that like. You see, so thirsty for the likes, this guy. It's unbelievable. Thanks, guys. And we will see you on the next one.